Well, hello. Thank you all for joining us today. It's a pleasure to host you here for this special field day highlighting a project that is multi-state. So we'll get a chance to see what's going on here in Iowa and in Pennsylvania. So thank you to all of our previous virtual field day attendees who have also submitted their evaluations to let us know what you think of these events and how we can work to improve them. So we will be featuring some video from the field, both in Iowa and Pennsylvania. So what we'll have you do is stay muted with your cameras off while the video is playing. And then following the video, you're welcome to unmute to ask your questions directly of our host today, or possibly submit them through the chat if that's what you're most comfortable with. So for those of you who are new to the Iowa Learning Farms Virtual Field Day series, thank you for joining us. We are based on campus at Iowa State University. We were established in 2004, and our goal is to build a culture of conservation, working with farmers and researchers to implement practices that improve water quality and soil health while remaining profitable. Our partners in doing so include the Iowa Department of Agriculture and Land Stewardship, the USDA Natural Resources Conservation Service, Iowa State University Extension and Outreach, the Leopold Center for Sustainable Agriculture, the Iowa Department of Natural Resources, US EPA Section 319, Conservation Districts of Iowa, Iowa Farm Bureau, Practical Farmers of Iowa, GrowMark, Iowa Agriculture Water Alliance, Iowa Corn, and the Iowa Nutrient Research Center. So again, just a little bit of housekeeping. Please do remain muted during the video and the speaker's presentation following. You'll be invited to unmute to ask questions, and we encourage discussion and dialogue. And at any time during the video or during the discussion, you're welcome to submit those questions via the chat box, and I'll be sure to get those directed to our speakers today. Following today's presentation, you will be receiving an email from Iowa Learning Farms asking you to evaluate today's field day, because this is just the start of the conversation. It's the exchanging of ideas. Taking this information and sharing it with folks who couldn't join us today via the link of this recording that will be included in that email as well is a great way to help spread the word about these opportunities that are growing both here in Iowa and in Pennsylvania. So please do return that, and if you would like, you can provide us with your mailing address to receive a free Iowa Learning Farms Net Gator as well. So today's project is sponsored by USDA NIFA, and I'm pleased to introduce Dr. Matt Helmers, the director of the Iowa Nutrient Research Center, and Dan Ciolkosz, Penn State Agricultural Biological Engineering Associate Research Professor. So without further ado, I'm going to go ahead and play the video. And again, feel free to submit those questions at any time.
Okay, today we're out at the Comparison of Biofuel Systems Drainage Water Quality Site south of Ames. This is October 19th, 2020, so we got a little snow on the ground today. At this site we have a few different treatments. We're looking at a traditional corn-soybean rotation. We have two continuous corn rotations where the corn residue is harvested. One of those we also put cover crops, winter cereal rye cover crops down. And then what you see behind me is we have two prairie systems. One prairie system that does not receive any nitrogen fertilizer, and one prairie system that receives about 75 pounds of nitrogen fertilizer per acre per year to try to maximize the above ground biomass. This site was established in 2009, and so this was bulk cropped. In 2009, we came in and put drainage systems in to monitor the individual tile lines. We have 24 individually drained plots at this site that we're monitoring for drainage water quality. At that time, in April of 2009, this prairie was seeded, so a diverse local ecotype seeding of prairie. So we've been monitoring cumulative drainage volume, capturing water samples for nitrate and phosphorus loss from this system for over 10 years now. And so what we've seen is we see where we have this prairie, we see about a 95% reduction in nitrate loss compared to our corn, soybean, or continuous corn cropping systems. And that is with or without the nitrogen fertilizer. So we are seeing nitrate concentrations close to the detection limit for nitrate nitrogen in that water that's leached below the prairie root zone, compared to about 10 to 12 milligrams per liter or part per million of nitrate nitrogen from our annual cropping systems. We do see about a 20 to 40% reduction when we implement the cover crops with our continuous corn system compared to the continuous corn system that doesn't have cover crops. The prairie that you see here is managed similarly from a standpoint of harvest of the biomass. So after first killing freeze, then this biomass would be harvested and quantified for how much above ground biomass might be coming from that prairie system. So that would be something that could potentially be used as part of anaerobic digestion. Some might even use it for bedding for livestock, those types of things. So with that type of system, we would expect to be getting a lot of the benefits that we'd get from prairie, but we are harvesting the biomass in this case. So one of the things to continue to look at is what kind of biodiversity benefits do we get with a prairie that might be harvested versus a prairie that's not harvested. But certainly as we think about the water quality benefits from this, we're seeing dramatic nitrate reduction benefits when we have this prairie out here. I will just comment that we have also looked at phosphorus in the tile lines. We see very little difference, very low levels of phosphorus in the drainage water, and really no difference between the annual cropping systems and the prairie that you see behind me. Okay, here we have our drainage water quality monitoring setup. And so we have each of the plots has an individual tile line at about 3 to 3.5 foot deep down the center, perforated. And that water then comes out one of the large PVC pipes down at the bottom and goes into an individual sump there. And then that water is pumped out of that sump through the flow meter that you see right here. And with that, we capture quantification of how much flow has come out of the plot. We have that hooked to a data logger so that we can quantify on an hourly or time basis how much water is flown out of that individual plot. And then here we have an orifice in here that the back pressure in the pipe forces a small portion of that water into a sample container. So this is a flow weighted or flow proportional water sample, which is really useful for water quality quantification. We get a portion of that water into the sample container, and then once or twice a week, we'll come out and collect a representative sample of that so that we can quantify the concentration of nutrients coming out of the plot and then ultimately quantify the load of nitrate or phosphorus that we're losing with that drainage water that would be going downstream. Okay, this comparison of biofuel system is really a multidisciplinary project. So a number of faculty from agronomy are heavily involved in looking at some of the soil carbon aspects, also just the agronomic management. So Dr. Matt Liebman and Dr. Michael Thompson are actively involved with managing this site. In fact, Dr. Liebman's group is the one that does all the agronomic management of the plots that you see behind me. All right, as I mentioned, this is local ecotype seed that was used to establish this prairie. So this is a tallgrass prairie type system. So the species are what would have been throughout Iowa prior to settlement. And so these systems, you see a lot of above ground biomass, but what's really fascinating is the density and depth of the root structure of these systems, probably extending down 8 to 10 feet for some of the bigger plants that we see here. So, not only a lot of above ground biomass, but a lot of below ground biomass as well with these types of systems. This could be a good choice for biofuels because it does provide a lot of environmental benefits, and it's putting a lot of roots back down into the soil. So over the long term, we would expect that it provides some soil health and soil quality benefits as well. While I'm an ag engineer, I would say these types of systems should also provide us a lot of habitat for things like bees as well as monarchs, because we're going to have a lot of flowering plants in here depending upon the species mixture.
Hi, my name is Dan Ciolkosz. I'm with Penn State's Department of Agricultural and Biological Engineering. And we're right here at the university's dairy barn facility, just on the edge of campus. So you see here behind us one of the freestall barns where the dairy cows spend their days, and behind that is the anaerobic digester that we're going to take a look at and talk about today. So here you see one end of the dairy barn where all of the feedstock is being produced, the manure, and that goes across the way over here to the digester. And here you see the large tank there, that's the digester itself. And then the curved roof, that's actually a flexible cover that allows the amount of biogas inside the tank to expand and contract as it's being produced, more or less. You see another little tank there on the left. That's the holding tank or the mixing tank where the feedstock is placed before it's injected into the digester. And then the building next to it, that's where typically you're going to have any controls equipment and the generator that would generate the electricity from the biogas, if that's what you're doing. Typically for manure, you need about a 20 to 24 day residence time of the manure inside that tank in order for it to digest properly. So you've got to think about how much manure your animal is producing, multiply that by the number of animals, and then times 20 to 24. That's going to tell you the volume or size of the digester that you need. And you're going to figure out pretty soon that that's going to be a pretty good sized tank. Prices really vary a lot from farm to farm because the design can vary. The type of system, you can have an in-ground tank versus an above-ground tank, and that all impacts the costs, as well as the electrical generator and the switchgear that's used to transmit the electricity onto the grid. That all has pretty significant cost implications. Digesters are pretty expensive things, and so typically it's going to be more than $1 million is what we've seen here in Pennsylvania for an on-farm digester. If you start combining and getting waste from other locations to add to your farm's feedstock, price is going to go up even more. Economically, it's something that the farmer has to be willing to do themselves. But like I said, it has to be something that you're willing to do. It's not just going to run on its own. You need to be interested in the digester, how it runs, checking up on it out of interest because it takes time and attention to make sure it's running well. The digester is a living system, so just like the cows or swine or crops need attention and care, so does the digester. A digester is going to be a lot cheaper to install if you can use all the energy on site because the various connection equipment is expensive. And you can definitely use the electricity on site. You can use the heat on site. There are a lot of potential uses for that right there on the farm. You even have the potential to take the biogas, compress it, and then use that as a fuel for equipment, for tractors, for trucks, for things like that as a transportation fuel. Let's say somewhere around a 500 animal unit digester, you might be able to produce somewhere around 100 to 120 kilowatts of electricity continually from the biogas. And then of course you have the heat that's coming off of that because the generator only makes use of maybe 25 to 30% of the energy in the biogas and turns it into electricity. The rest ends up being heat. So generating electricity and connecting it to the grid, that's all been worked out. It's pretty standard and straightforward as long as the utility company is willing to let you do it. If you want to do other things, for example, if you want to take that methane from the digester and inject it into the natural gas pipeline, that's going to take a little more extra effort to upgrade the quality of the biogas that you're producing and then make the necessary arrangements to allow for that to be used in the pipeline. Anything that a cow can digest, the digester can digest, right? And so you can put crop material into a digester and it will be digested in there to at least a certain degree. Food waste is an outstanding feedstock. A lot of farmers love to get food waste from nearby processing plants or grocery stores, anything they want to get rid of. That goes into the digester. Naturally, it's very digestible because that's what we eat. We digest that. And so it's a really good supplementary feedstock. Fats. Fats are very high in energy. We know that from our own diet. They also produce a lot of energy in a digester if you have a source of waste fat that you can put into it. The nutrients that are in your feedstock do not disappear somehow in the digester. They come out. And they generally do not come out in the biogas. They come out in the liquid and the solids, the effluent. The digestate it's also called. And so those nutrients are still available and are a big part of the economic value of what comes out of the digester. You definitely want to take advantage of that and utilize those nutrients. If you're interested in possibly having a digester on your farm, the first place to get started is, of course, with your local extension agents, to talk to them, find out if there's another farmer nearby that you can go take a look at their operation. See if you can get a feasibility analysis. There are a lot of programs through USDA and through Extension that can help you answer some of those first questions to see if it's just a good idea, or is it a good idea that's actually going to work for you.
Great. So Matt did share a link in the chat there for this grass to gas project. It's being led by the Sea Change team with representatives from Iowa State and Penn State. So at any point, if you have a question, feel free to enter that into the chat box or go ahead and unmute and we'll get those questions answered. So some questions that have come in already. Matt, this one was for you. Recommendations on how often prairie could be harvested without potentially being outcompeted by weeds.
Oh, well, that's a good question. I don't know if Matt Liebman is on today or not, but one of the things I would say, we've had that out there 10 years and it's been harvested quite frequently, and it still has a good, I don't think it's been overtaken by weeds. It still has pretty good diversity in there, at least from what I've seen. Again, I will have the caveat that's coming from an ag engineer, but certainly you saw at the end of the year, that snowy time period, I didn't know snow was going to start in October and never end. But that good diversity out there still. So, and hopefully, I mean, I think it showed up in there that seeing some differences between that fertilized prairie and the unfertilized prairie.
So Dan, out of curiosity, you mentioned kind of various outputs from the structure you have there at Penn State. Someone's curious, what is the biogas actually being used for at Penn State?
So we're generating power from it right now. And so that's the most common use in Pennsylvania, is typically a farmer is going to generate electricity, sell that electricity back to the power company, and then use any of the excess heat right there on site to preheat wash water, dry grain. We've seen some applications where they're drying grains with the heat as well.
So any modifications for here in Iowa where we've got a lot of hogs, a lot less dairy, any modifications to the systems to processing hog waste versus dairy waste?
Yeah, sure. So there are going to be some differences when you're running with hog waste. We have several hog farms that have digesters here in Pennsylvania, and they work fine. The main difference is just the way that you're going to be handling the manure, because it's going to be a different consistency, different properties. So there are certain kinds of pumps that work better with swine manure, certain just design details that people have learned over the years that are incorporated into a swine digester that would be different from a dairy digester.
And I guess one thing I would, not on the digesters, I know nothing about that, but just to add that, you know, kind of one of, I think of this project, the grass to gas, is to see how we might be able to combine that herbaceous material with the manure for anaerobic digestion. So, you know, that project is just getting started. And so I think they'll, you know, hopefully we'll have more virtual field days on more details of some of these things into the future, more good video on thinking about combining all these and how we might be able to make it work in Iowa, where, yeah, like you said, Dan, and Liz, we have a lot of swine manure. So.
Yep. Hey, Matt, this is Jackie.
Yeah.
I'm just curious. So isn't one of the goals then so that we could increase prairie or some other good quality biomass in some of these marginal areas, as well as have a use for all that vast amount of manure we have? So isn't that what the ultimate goal is, to see if we can't get more prairie on the land?
Yeah. And I think could we start using some of those areas that maybe aren't as productive for cropland and could they be very productive for prairie, and then we can use that in, in kind of renewable energy production. So, yeah, I think there's going to be some work looking at kind of where one might get the greatest benefits from putting herbaceous material.
So, Matt, this one's kind of tied to yours, but maybe is a question for the larger Sea Change team. Is there communication with USDA NRCS on the utilization of like a 10-year CRP prairie project for biomass production, or are they against it?
That I don't know if Dan has that. I mean, so there would be, the way I would understand CRP, there are probably limitations for harvesting that, but that may be something that to think about into the future. Are there ways to meld some of these things together, and maybe it's not full CRP benefits, but some some benefits under that.
Yeah, no, every state has the ability to adjust its rules regarding the use of CRP land, and so far we haven't convinced them here in Pennsylvania to allow harvest, and maybe for good reason, but that's certainly something we're talking about, to see if there are ways that we can achieve both objectives, renewable energy and conservation and ecosystem services.
Dan, I think this one's for you. Do you have to shut the system down to get the remaining products, the digestate, like out of the fermenter, or is it a continuous system?
Great question. So it is a continuous system. So it's coming out, it's going in one end, coming out the other end, more or less continually. Now you will get a slow buildup over time, sometimes of some grit, some heavier material that doesn't seem to come out. Some designs are more prone to that issue than others. So maybe after 10 years of operation, you may have to shut it down, take the cover off and clean it out, but it's not a regular thing.
Can I ask Dan a question? Maybe it was in there. How many head facility is that operating on there at Penn State?
That's a little tricky to answer. We have 200 cows, but then they're also bringing over the swine manure and various other things as well to feed into it from time to time, which is one of the purposes for having that in-feed tank as well. So I don't know what the exact number is. It's probably less than 500 animal units, a little less than what is economical. One of the real drivers at Penn State wasn't pure economics, but was actually reducing odors, because digesters do a lot. They really reduce odors dramatically. And I don't know if you saw, but the dairy farm is very close to the football stadium, and the football fans don't always appreciate that dairy air, as it were. So that was a big reason that helped us to get that put in place and get it approved.
Does it use any food waste from the university?
No, right now, actually, all our food waste is going to a composting site that's been in operation for at least 10 years here at Penn State. So we couldn't convince them to give up their food waste.
Okay.
Someone's curious in how challenging it is to convert the digester gas to transportable fuel for internal combustion engines.
Sure. So the main issue is that biogas is about 60% methane, and almost all the rest of it is carbon dioxide. Now there's some sulfur in there as well, and some water vapor. And so you need to definitely get the sulfur gas out, the water vapor, but then the CO2 takes a bit of effort, because of course natural gas is almost pure methane. So basically, if you can get rid of everything that's not methane, it'll be very adaptable to pipelines. And so the technology that's used is something called pressure swing absorption, where they have to pressurize the gas and then unpressurize it, and it tends to be expensive and only economical if you have a really, really big system right now. So it would be great if we could figure out some technologies that work effectively at a smaller scale, but that's where we're at right now.
So a couple more questions about kind of the end product. Someone's curious, do you see much digester end product marketed as dried, bagged fertilizer? Is it mostly land applied? And possibly is your dairy farm using those byproducts then for bedding?
Yeah, great question. So in Pennsylvania, it's typically used only for bedding. So they'll stop using sand or whatever they were using before and use the digestate as bedding on farm. They might sell some of it to a neighboring farmer because they typically have a little more than they need for that. There could potentially be other markets, but it's been so successful as a bedding material in terms of animal health and milk quality that farmers haven't really looked any further at this point.
So I guess is my own curiosity, the digestate that's coming out, is there a separation process to get the dry bedding material from the liquid?
Yeah, oh yeah, thanks for asking that. So they'll typically have some kind of a solid separator that squeezes the liquid out of it as much as possible, gets it down to about 50 or 45% moisture content. The liquids are then kept stored separately and are land applied most often. But then the solids are saved and used as bedding.
All right. What kinds of credits what kinds or amounts of credits should a grower get from the nutrients out of the digester? So assuming land applied, what could they count towards that nutrient application? It might vary based on the feedstock, but how do you recommend that?
Yeah, in general, the nutrients that you put in are the same as what's coming out. So, but if you're separating out the solids, you have to get it, it's going to take a little bit of testing and figuring out. The only change I know in terms of nutrient value is that the nitrogen might be a little bit less mobile, but only slightly. So it's probably not even worth taking into account when you're sorting out your nutrient plans. So sorry, that's a bit of a non-answer, but I think that's about as what you have to do is just kind of feel your way through it.
A lot like doing a manure management plan, doing your testing and figuring out what's actually in it.
Mm-hmm.
Someone's curious, are there any concerns about any unintended consequences in terms of any toxins released by the digesters? So in the digestate process.
Yeah, I haven't seen any issues come up lately. Although with the interest in bringing in additional material from off-site, food waste and things like that, there's definitely potential for that. Now, I think if there are toxins of one kind or another, the farmer is going to see that in terms of the biogas production, because it's probably going to be detrimental to the microbial population in the digester. And that would tip them off that something needs to be checked before they do anything with that digestate.
Someone's also curious, so we've talked about manure. Can you use human manure instead of only animal?
Absolutely, you can. And wastewater treatment plants around the country, many of them do have digesters and generate power from those digesters. That's another interesting possibility that we've looked at here is some of these wastewater treatment plants have more capacity for feedstock, and maybe a nearby farmer would be interested in taking their manure to that facility for processing, because these wastewater treatment plants are often pretty advanced in terms of nutrient removal and things like that. So there might be situations where some kind of partnership like that could work out.
All right, Matt, one for you. Any concerns to wildlife benefits when you harvest the prairies?
I think that would be, one of the things is it is done late in the season, as I said, after that killing frost. So it wouldn't be during nesting season. I think that is something to kind of look at into the future. Do we accrue as many wildlife benefits when we are harvesting it or not? So I think that's an important question. But one thing is just to kind of note when that harvest is happening, it would not be during the active, at least what we've done there. It's not been during the active nesting season.
Someone's curious, Dan, if a dairy uses sand bedding in their free stalls, has that sand accumulated in the digester?
Yeah, that's a big issue. And that's what gets the engineers arguing with the animal scientists, because the animal scientists love sand bedding and the engineers don't want to have to deal with it because the sand can accumulate in the digester. It can, it can be very corrosive to the pipes and pumps and things like that. There are some techniques and ways for doing sand separation from the manure that succeed to one degree or another. but it sure is a lot nicer if you don't have sand in there from an engineering point of view. And so not all animal scientists are excited about the idea of using the separated solids of the digestate for bedding. But I keep coming back and saying that the farmers that have used it are really, really happy with what they see. So we try to convince them that it's worth at least thinking of switching from sand, but you're right, it's a big issue if the farmer really wants to use sand for bedding.
Matt, someone had a follow-up comment that overwintering habitat would certainly be impacted.
Yeah.
So maybe recommendations on not swath harvesting or patch harvesting.
Yeah, that's a good point. And maybe, maybe it's something that you don't harvest the whole thing. Yeah, you do kind of strips of harvesting depending on what it is. That's it.
Or at least mow shortly before deer season opens. Perhaps.
Yeah.
So kind of keeping on that prairie harvest, there was one that just came in. How were the prairies harvested? What kind of equipment and machinery were being used? Do you happen to know?
I don't. I can try to find that. Maybe
Okay.
they could, if you have that contact information, Liz, we could get that, because
Certainly.
Yeah, to say specifically, I can.
So Dan, Penn State's a little bit farther along in the use of anaerobic digesters. So what are some of the barriers of adoption that you're seeing? The price tag is large. How long before it pays for itself?
Yeah, so the price tag is large. The long payback, some of these farms with incentives are seeing paybacks of 7 or 8 years, depending on the specifics of their situation, the size of the operation, the design itself. I think that's the major issue. But the second one is the digester isn't like a like a barn that you can just build it and ignore it for 10 years. It's something that needs to be cared for. And so you really need someone who's interested in the process and wants to keep watching over it. It really is a living system and it requires someone to manage it. So that would be the other big thing. If there's not the right person there to run the digester, it's not going to succeed. And so we see, for example, farms where there are brother partnerships, where one of the brothers is focused on taking care of the cows and the digester, and the other guy's out in the fields taking care of growing the feed or something like that. That's when you see it happening and working well. If someone's kind of excited about what a digester is and doesn't mind stomping out in the middle of the night to check something because he or she is curious about it and likes to see what's going on.
Someone's curious, what kind of exhaust is produced from the energy generation in the digester?
Right. So it's it's going to be, you're going to be burning the methane, so you're producing CO2 and water vapor. But depending on your facility, you might have incomplete combustion, so you might have a little bit of methane coming out of your engine generator, depending on how it's designed or set up. So that's a little something to worry about. The SO2 is something you want to be concerned about, because that can be very toxic, although generally we haven't noticed issues with digesters. But I think the other thing to keep in mind is that there are going to be times when you're producing more biogas than you can use, or the generator has to be shut down for maintenance. And at that point, you have to do something with all that biogas that's being produced. And so you need to install something called a flare, which is just a pipe with a little pilot light on it to burn off any of that methane that's being produced that you can't use at the time, because methane in and of itself, so it is combustible and flammable, but it's also a very potent greenhouse gas, something like 20 to 30 times as effective as carbon dioxide. So you're much better flaring that off, turning it to carbon dioxide, than emitting it into the air as methane.
So this one is a question for both of you, if you want to take turns. What are some barriers to prairie adoption, both here in Iowa, and how suited is prairie to Pennsylvania?
So I can start. Some of the challenges to implementation, I would say, it takes time and it takes some management. And Dan talks about kind of the management of the digester. That's something that comes along with prairie. It's going to take more management than if we had a monoculture of, say, brome grass. So we're going to have to do things. First we're going to have to have good seed bed preparation. We're gonna and think about what we're planting behind, because there could be some plant back periods after some herbicides that are out there. That's kind of what I mean by seed bed preparation. And then we'd want to think about, mowing that first couple years for weed control, so that we try to, get that diversity established. So there's definitely going to be more management in there for that prairie, and a little patience involved, I would say, before we're going to have, a lot of diverse biomass.
There never has been a lot of prairie in Pennsylvania, maybe a little bit. There was some evidence of, in the 1700s, some sort of prairie areas in some of the valleys. They suspect it was probably kept by the native tribes as hunting areas, so they would burn it down regularly in order to create habitat. But once again, it's not a lot, but there's definitely scope for it in Pennsylvania, but in patches, in strategic patches. There are a lot of farmers interested in having a little bit of prairie in different spots for the ecosystem services, for the aesthetic value of it. Pennsylvania's landscape is definitely a patchwork, and there are a lot of people, for example, living in rural areas that aren't drawing their primary income from the land itself. So there are opportunities there to try to incorporate prairie in strategic ways that is valuable for the landowner as well as the ecosystem.
So Liz, I can always count on Dr. Matt Liebman to be thorough with his publications. And so I found the one that Megan Jarko, Matt, and probably others wrote, but that they talked about the prairie and actually kind of looked at the different composition, and that the above ground biomass was harvested after plant senescence in mid-October from 2009 to 2011, kind of that period of study. It was harvested with a self-propelled forage harvester, John Deere model 5830, to a cut height of between 8 to 20 centimeters. So, 8 inches.
Great. Okay. Someone's curious, Dan, you mentioned that the digester was, one of your arguments was odor reduction. So how significant has been the odor reduction?
I don't have a specific number in mind. We do some research on that here in the department. We have an odor lab, which is kind of fascinating because they have this big machine in the lab that you walk up to and you stick your nose against it and you turn a dial until you smell something. It's kind of fun to watch. But anyway, it's dramatic, on the order of 90% reduction. Don't quote me scientifically, but it's somewhere close to that. So it really is dramatic. And farmers that have installed digesters have commented on how much happier their neighbors are since they've installed a digester because of the odors or the lack of odors.
So I guess based on the size of the digester there at Penn State, what was your estimate on like the amount of prairie that would be needed to be a feedstock for that digester?
Maybe that's what we'll find out as part of the project.
That's a real good question, because we're not sure yet. A lot of prairie grasses are not readily digestible immediately. And so some of the research we're working on is figuring ways to process that insight and do things to it to kind of unlock the digestible portion of those grasses inside that digester. So once again, it's a bit of a non-answer because we don't know yet, but we hope to find out in the coming years.
And I guess another question related to that, that we're probably still looking at, but prairies have grasses and forbs. Is there a percentage of each that you strive for in that final biomass product? So something we'll be looking into.
Yeah.
What would the carbon balance be if you combine the prairie biomass with the digester?
Well, it's going to depend on your ratio of how much of one you're going to put in versus the other. But you're definitely, that's a big issue. They talk about the carbon to nitrogen ratio of your feedstock. And so some manures are too high in nitrogen, they're hot. And so they're not ideal, even though we use them in the digester. whereas this prairie grass is typically going to be higher in carbon. So there's potential to get a optimized combined feedstock if we do things right. I know that's a big issue with poultry manure. It's really hot stuff. So we have a project going on right now taking a look at whether we can combine the two and end up with a synergistic effect and get much better production of biogas as a result.
So kind of a 2-3-part question here. Open to either of you to take on. So what environmental problem are we solving here? The need to get marginal land out of row crops? The need to do something with all of our manure?
Yeah, I don't.
Well, the manure doesn't go away. Keep that in mind. You dump it in that tank, it has to come out again at the other end. So you may be losing there's a small amount of mass that's lost in the form of the biogas, but the vast majority of it is still coming out as solids and liquids. So I don't think we're getting rid of the manure, but maybe we're getting some value out of it that we didn't get before.
And perhaps there could be, I don't know, you'd have to look at what the uniformity of that product is coming out and when we put it on the field, because one of the things with a lot of our liquid swine manure is how variable that product can be. So if we could reduce the variability, we might be able to reduce the nutrient use efficiency out in the crop field. I do think that if we think about some of these areas that may be more maybe not as productive for cropland, thinking of Iowa, they may be, if we look at some of the work that Stephen Hall at Iowa State has done, some of those could be hot spots of nutrients because there may be some of the wetter conditions that maybe produce a little more nitrous oxide and have quite a bit of nitrate leaching and maybe not good nutrient use efficiency for the crop. So if we could put something like prairie in there to provide a lot of water quality and environmental benefits and then, get some value out of that in anaerobic digestion, it seems like there could be some benefits.
So this person's curious, can you get a bigger bang for the buck by using prairie grasses first as bedding and then as feed for the digester?
I don't see why not. I don't see why not. Now do you use a lot of bedding for swine? In general, I've seen just concrete floors. So
yep, that's what I was going to say.
Dairy, there's potential there. Yeah.
Yep, that's what I was going to say. It's really going to depend on the species because, at least how our swine systems, there probably wouldn't be. But if we were in more, perhaps some beef operations, maybe there's more potential there.
Mm-hmm.
And I was looking to see if Emily was on, but does either of you know if anyone's using Miscanthus as a feedstock for digestion?
That went into my mind as well, Liz, because I know Emily's been looking at using Miscanthus for poultry house bedding. So whether, kind of how when that came out of that facility, what might be any potential?
Yeah, I don't know of active projects that are doing that, but the principle should hold. I think part of the issue is our project we're working on is USDA funded, and switchgrass is an all-American plant, whereas Miscanthus is not. So we're going to start with switchgrass, perhaps, but there's no reason technically why the Miscanthus wouldn't be effective as well.
Kind of got a couple of chats here that came that the companies, there are some companies interested in Miscanthus, and that, kind of the environmental problem, opportunities to recouple perennial crop and livestock systems there, maybe, that opportunity.
And it's great you mentioned the USDA, Dan, because there's a question that came in for you about addressing more specifically about what USDA grants are out there to help fund digester construction.
Right, so both the USDA NRCS and the USDA RD, so that's Natural Resource Conservation Service and Rural Development. Those are two branches of USDA. They both have programs that can provide pretty significant grants and or financing for digesters. And so we've had some farms here have added over 50%, up to 70% of the cost taken care of by some of these grants and programs. And so I think the best thing to do is to, if you're interested, is to check in with your local NRCS office and your local rural development office and find out what specifically they're offering, because the way that it's rolled out can vary from state to state a little bit. And of course, talking to the people who are directly involved is going to be really helpful in letting you understand what's really involved, because some of these grants are pretty easy to apply for and some of them can be pretty challenging. Yeah, the NRCS and rural development are the two USDA programs that I know of that typically provide pretty significant support for digesters.
And so this question, I'm going to open it up to either of you to tackle first or add on to. From a greenhouse gas limiting perspective, how do these systems compare to just diversifying our rotations, getting livestock out of confinement, and reducing fossil fuel inputs into the ag system? Big question.
I'll let you take this one, Matt.
No, yeah. I mean, I think that's the type of, life cycle assessment that should be looked at as part of all of these efforts, because we do want to think about it as an overall system and some of the impacts, and then think about in certain areas, what's the existing infrastructure and capacity for some of the more diversified, crop livestock systems.
Yeah. I mean, our favorite answer here at the university to any question is it depends, right? And I think that's the correct answer to that question, though, because like I was saying, if you're leaking a lot of methane into the air versus doing a good job of containing it all in a digester, that's going to make a huge difference in terms of overall greenhouse gas impacts on it. So there's a lot that has to do with how you're doing it. Once again, we love those answers because we can be vague about them. And also it means expertise and experimentation is needed, and we love that too. But I think that is the real answer to a situation like that. It's a little too complex to be able to come up with a simple answer just yet.
Someone's curious how scalable the digester technology is. How small is too small? How big is too big?
So it kind of depends on what you're trying to do. If you're generating electricity and trying to make it pay off money-wise, then you probably need it pretty big. Like I said, about 500 animal units of size. If you have a use for the gas to produce heat only, for example, you can probably make something much smaller and make it pay off. I've seen some people just do sort of home scale digesters where they put their food waste and things like that in the backyard. We have graduate students that get excited about that. And it's successful to its own degree, but it's definitely not going to have any economic impact on their life. So you have to look at what you're trying to do. The electrical generation and interconnection equipment is really expensive. So that really bumps up the size that you're going to need in order to make it pay off.
And just for folks, Matt did share a link about capturing and sequestering carbon dioxide from the digester. So there's a link there to an article if you're more curious. And Matt, did you want to elaborate on that anymore?
No, that was that Lisa Schulte Moore put that in the chat box. I wanted to make sure everybody had access to that.
Great. So I've got one more question so far. Then we'll let people know how they can get their CEU credits and wrap up here. Curious, what can go wrong? We know we've had some failures for digesters in Iowa. What are the downsides?
I'm supposed to give a short answer here. Yeah, there are things that can go wrong. It can get pretty ugly sometimes, and there have been failures.
I'm glad we're recording this because this can be turned into a FAQ of kind of the good and the bad. Right?
Yeah, but a lot of these digesters that we had in Pennsylvania have been custom designed, one-off kinds of things. And so each one seems to have a little bit of another problem or issue that comes up. There are issues of things like crusting or foaming of the material inside the digester, and it just fills up with foam. And then what do you do with it then? There are issues where if your pH gets out of balance, you can get something called souring, where the digester pH just drops and it kills off all of the methane producing bacteria, and you just end up with a horrible stinky mess in there that you have to clean out. That's bad news. You don't want that to happen. Just the equipment that's not proven to work well with biogas. You know, people try one thing or another, those are sort of the things that the learning pains that people have gone through as they've been finding out what doesn't work and what doesn't work smoothly. But then the other thing is the people side, is that you need, like I said before, you need the right kind of people to be involved in order for it to work. The people that are willing to stay involved and pay attention to what's going on.
Great. So there's still time to get a few more questions in. But again, if you did attend today for a CCA CEU credit, here's that information. I'll also be sending it via the chat, so you can just copy my email directly from the chat box if you need your CCA credits. I'd also invite you to join us in a couple weeks. We're going to be exploring the Clear Creek watershed, looking at some wetlands that they're working on there as part of the Iowa watershed approach. So please plan to join us March 4th if you can. Again, all our virtual field days are recorded, so if you can't make it live, you can always check them out on our website. So let's see if any more questions come in. I've got one more. All right. Matt, any problems or concerns with prairie establishment?
Sure. I mean, it can be, you know, it can be a challenge, or as I said, it takes time. You got to kind of be patient with it. And so I think we're learning a lot more resources. I would look at things like, I would look at some of the resources out there on the Prairie Strip site or the Tallgrass Prairie Center. We're fortunate, if you're from Iowa, we got, you know, the Tallgrass Prairie Center at UNI, led by Laura Jackson, is a great resource for prairie establishment. And so that's where, you know, that establishment is a little bit more challenging than, you know, some of what we might plant out there. And so, but I think there are a lot of very qualified individuals, you know, especially throughout Iowa, that can help with that.
And I know we're working to establish Prairie with farmer partners as part of this project as well. And a few of them have different types of operations, including one organic. So there's lots of different ways to get Prairie established to match the system goals of the operators as well.
Yeah, so as this project goes forward, we should have some kind of case studies from those on some of the things they've used, since they're all going to be a little bit different.
All right, kind of last call for questions here if you want to get those in. I'd like to thank both Matt and Dan for their time today, both for the live presentations, but also for helping us get those videos created. Again, this is being recorded, will be available on our website following that. The video that was played at the beginning will also be available on our YouTube channel on its own. So you can check that out if you happen to join just a little bit late and missed any of that. So thank you all so much for attending today, and stay warm, and we'll see you again hopefully soon.
Yep. Thanks, Liz. And thank you to everyone for coming.
Yep. Thank you.